normal, binomial, and the Poisson distribution in detail. So let's begin. What is probability distribution? But before going to define probability distribution, it is very important to understand what is the frequency distribution, which is also a part of the probability distribution. So frequency distribution refers a list of observed and actual frequencies of all those outcomes of a possible experiment that actually occurred when the experiment was being done. This is a frequency distribution. What is the probability distribution? It refers a list of all those probabilities of all the possible outcomes that could possible to occur if the experiment was being done. It can be described in the form of the diagram, in the form of table, in the form of mathematical formula, or using the various types of distributions like binomial, uh, Poisson, or normal distribution as well. So let's categorize the types of probability distribution. Probability distribution is classified into two categories. The first one is discrete probability distribution, and the second one is continuous probability distribution. When it comes to the discrete probability distribution, it is also classified into two categories, that is binomial distribution, and second one is Poisson distribution. Binomial distribution is that probability distribution model that obtains one out of the possible outcomes from the various parameters on the various circumstances or situation. That's called the binomial distribution. When it comes to the Poisson distribution is that type of probability distribution model that obtains one out of the possible outcomes in a population. That's called the Poisson distribution. These two categories includes the discrete frequency distribution. When we talk about the continuous probability distribution, it refers to normal distribution, as normal distribution includes the continuous data which describe in a bell-shaped curve, which is shown as in the possible slides as well. So let's begin the probability distribution. The first one is discrete distribution and continuous distribution. When we talk about the discrete distribution, we always talk about the random variables which take only a limited number of values. So under the probability distribution, when it comes to the discrete distribution, a researcher will take only a limited number of values, and from that values, the researcher will able to find out the possible outcomes from each trial. For example, number of hits in a two tosses. When we talk about the toss a coin, there are two possible outcomes, that is the success and that is the tail and head. That means it would be a success, one would be a success, and one would be the failure. And that's called the discrete distribution. When we talk about the continuous distribution, a random variable can take any value. As I already told you, when it comes to the normal distribution, a continuous data will be considered and it will take any value from the given sample. For example, in a height of the students in a classes, you can talk about the weight of the teachers in the particular school. That's called the continuous distribution, which are classified into continuous series which have no and. That means it includes the infinite values, but when we talk about the discrete distribution, it includes the finite values which have a very limited number of values which cannot be included in an infinite way, which have an and of certain values only. So that's called the discrete distribution. So let's talk about one of the example of probability distribution. It is, as I told, that probability distribution can be described in a tree diagram, which are also always called the probability diagram. So let's talk about this diagram. A fair coin is tossed twice. So let's talk about the possible outcome. First, we need to find out the possible outcomes. When we talk about the coin, there are two outcomes, that is tail and head. So in the second round, we talk about the possible, you can say, trials. That is, when we talk about, let's twice we have to toss. So on the one side, a head would come. On the second side, the tail would come. When we talk about the, let's say, on the first trial, the tail has been come. So there are two possible value, or two possible outcomes, that is head and tail. When we talk about the first trial which comes head, there is two possible outcomes, that is head and tail. Let's talk about the among all the round, there are four possible outcomes. When we talk about first and second round, is a combination of first and second round. There's this H, that is head. When we talk about the second round, that is head tail. When we talk about the third possible outcome, is tail head. So when you toss a coin and it comes tail, so under tail there is also two possible outcomes, that is head and tail. So on among that, when we combine the rounds, we come up in the conclusion, that is tail head and tail. So these are the four possible outcomes, which called head tails, tail head, and tail. So these are the attached probabilities, that how to calculate the probability of head tail head, and tail. So this is, so in fact, when we spin off, you can say one coin has no influence on the spin off to a second coin. You can say whether it's head or tail. So let's calculate the probability. So when we talk about the probability, is a half of two possible outcomes, that means 1 by half. And we talk about when we talk about the one head, probability of head, we talk about the half. Then the probability of another head, we talk about the half version, so it becomes 1 by 4. So when we talk about the probability in the second HT possible outcome, the probability of H, or we are talking about the probability of H, that is half, because under the head round there are two possible outcomes, that is H and head and tail. So automatically, when we talk about the probability of head, that is half each. When we talk about the tail, that is half each. So when we calculate the probability of HH, that is half into half, 1 by 4. When we calculate the HT, that is head and tail, the probability of head and tail, we talk about half by half, that we talk about 1 by 4. When we calculate the probability of tail and head, that means half into half, it's 1 by 4. Same in the category or outcome of tail and tail, that is probability of tail, that is half into half is equal to 1 by 4. So when these are the probabilities that we attached to the head and tail. Now we need to calculate the overall probability. There is a question given on the screen, that is probability of at least one head. So we need to calculate at least one head. We already calculated the probabilities of all the possible outcomes. So let's talk one heads. So out of the four possible outcomes, there is only the three possible outcomes which includes head, that is HH, HT, TH. So when we add both all the probabilities, we get the answer of probability of at least one head. So when we calculate the probability of at least one tail, again there is a possibilities where the tail has been included as HT, TH, and TT. So we have calculated the probabilities. Just add the probabilities. You will get the probability of at least one head or the probability of at least one tail. So this is the way to calculate the probabilities. So when we talk about the probability of head, we always talk about, when we talk about probability of head, there are two possible outcome, head and tail. When we talk about the tail, we always two possible outcome, that is head and tail. So when we combine these probabilities, so you will get the values, that is 1 by 4 each, and accordingly it will be calculated. Let's talk about the binomial distribution. What is binomial? The prefix bi means two or twice. That means every trial has two possible outcomes. So if we talk about the toss a coin, that is the two possible outcomes, that would be head and tail. Or you can say, and the only two outcomes, that is head and tail, it means it would be a success if it comes, it would not be a success, that means a fail or failure. So that is called the binomial distribution. So binomial distribution can be easily understand that it is a process of a probability of a trial with two and only two outcomes, and that's called the discrete distribution, which always includes the finite, you can say finite values or a limited values. As I said, their values are limited and the outcomes are also limited, that is 2. The binomial distribution this particular concept has been discovered by the Swiss mathematician, that is James Bernoulli, in 1700. So it is one of the oldest type of the probability distribution, which includes in all over the world in mathematics and statistics. That's the main reason it is also called the Bernoulli distribution or the Bernoulli theorem, which includes the mathematical formula and the variances, standard deviation, mean, and how to calculate the probabilities using the different measures of central tendencies. Uh, let's talk about the binomial distribution. Binomial distribution includes only two possible outcomes. Like for example, when we throw a coin, it's a head and tail. So these are the head trial and tail trials are totally independent to each other. If the spin off of one coin cannot be influenced the spin off of the other side of the coin, that is tail. So there are two possible outcomes, that is P and Q, the probability of success and probability of failure. So if any question has been prescribed with that you need to calculate the probability of success and the probability of failure, or let's say a probability of at least one head or a probability of at least two tails, then accordingly you need to calculate the probabilities of the head or tail. Next is binomial distribution. As I already explained, it is also known as Bernoulli distribution and Bernoulli's theorem. And this theorem has been published 8 years after the death of the James Bernoulli in 1719. That means this theory has not been published, has not been implemented before, you can say, or at 1700 years. But it has been implemented, has been published online, that is in 1713. Finite numbers of trial, which always been include, as it is a discrete distribution, so always include the finite number of trials with their exclusive and exhaustive outcomes. These are the theoretical examples of binomial distribution. So if you are appearing in an exam, so there are the two possible outcomes, either you pass or fail. So if we talk about the number of trials like survey and experiment to be conducted, this distribution is very useful. And it is also very useful when each outcome has an equal chance of obtaining or attaining a particular value. So binomial is the best trial or a best, you can say, method of probability distribution, where all these, when two possible outcomes would be there, that means this approach would be very useful. Features of binomial distribution: it is used in such a situation when experiment results has only two possibilities, that is success and failure. So experiments we talk about the survey, we talk about the questionnaires, whether it would succeed to get a possible results or not. And there is a mutually exclusive outcome. That means one outcome cannot be influenced to another outcome. So all the trials are totally independent, so no influence or any other you can say outcome. The probability of success in each trial is always being constant, so there is no changes. If any values to be attained, then also the whatever the probability of success will remains the same. There's also another examples that binomial distribution is used for purchasing a lottery, whether you are going to win money or you are not. So it would be a success and failure. So when we talk about the two possible outcomes, we always talk about the binomial distribution. It always talk about the tosses the coin also head and tail. So there are 50% of the probability. That means 50% of chances the outcome would comes under the head, or would comes 50% of chances or would comes under the trial. So that's so tables the whole. So in this particular parameters, the binomial distribution approach or model will be adopted. So there is also another examples, that is election polls. So whether the party A or party B would win, or party B would win, or maybe lost. So whether by implementing any policy, the government always, you can say, expected results within the specified period or not. If you see the election polls, only the, you can say, predicting the results, predicting the election polls, that whether which you can say party could win, whether A or B or C or D. So before that, the binomial distribution approach will be adopted, and accordingly, the predicting results would be will be shown among the public. So that's one of the good example of binomial distribution. Assumptions. So they obviously, when we talk about the binomial distribution, assumption has always been very important, as it is depends upon the question, and it included in the question about the success and failure, about the values, about the size of the sample size. So assumption will be followed in such particular situations. So there are, when we talk about the assumption, there are three possible or main assumption of this distribution. Three distribution can be applied only in those situations where the events are mutually exclusive. Two options, unlimited trials. So that's called the success and failure. The size of sample must be finite. That means it should be fixed. The third assumption, that is the success is denoted by P and the failure is denoted by Q. So there is a mathematical formula, that is the sum of both is equal to 1. So when we calculate the probability of success, that is 1 minus Q, and when we calculate the probability of failure, that is 1 minus P. So this is a very small and limited formulas which will be used in calculating the probabilities using this approach. So it's a symmetry of binomial distribution. So when we talk about the values, when the answer, the particular exact fixed value to become, so how you will denote, how you will interpret that value, and that's called the symmetry of binomial distribution. So binomial distribution is symmetrical when P is a probability value, that is 0.5, or when n is large. So when the n number of values is large and the binomial distribution is symmetrical, that means when it is symmetrical when P is 0.5, when n is large. Binomial distribution is negatively skewed, that means a peak of occurring at the right center of the, when we talk about the shape of the skewedness, so when we talk about the mid, that is the peak point, that is called, or we can talk about the right side of the peak point, that's called the negatively skewed. When we talk about the left side of the peak point, we talk about the positively skewed. So when we talk about the binomial distribution, which is negatively skewed, it's called a asymmetrical distribution when p-value is greater than zero point 0.5. Like for example, p, if it is 0.10, p it is 1.7. That means it is a negatively skewed. So when we talk about the binomial distribution, which is a positively skewed, where the peak point occurring to the left. So when we talk about, this is a peak point, and the peak point of the curve, that is a bell shape, and the midpoint of the curve, that is a peak point, the highest point. So when we talk about the highest point of this curve, so if it goes to the right, it is called the negative skewed, and when it goes to the left, it called the positively skewed. That means if the positively skewed means if the p-value is less than the 0.5, it's called the positively skewed. When the p-value is more than or greater than 0.5, it is a negatively skewed. So accordingly, whatever the value would comes, whatever the value p would comes, this is a way how to interpret it, the binomial distribution values. Next one is binomial distribution criteria. There are two most important variables, that is n and p. So n, what is n here is that how the number of times the experiment has been conducted. P represent the possibility of one specific outcome. So whatever the trials has been given, so number of trials is also called n. The number of times is also called n. So P stands for the possibility of one specific outcome from the number of from a finite numbers of times, or you can say the finite numbers of trials. That's called P. So these are the two main variables which will be used in the binomial formula. This is the main formula of binomial distribution. That is, the B is equal to x n p is equal n. It's cumulative. That means that is x into px by 1 minus p n minus x, where x would be 0, 1 is a finite series. B, what is B here? B is the binomial probability. X is the total number of successes. P is the chances of, that means a probability of 50% chances, 60% chances of a success on an individual experiment. And N is a number of trials. So when you multiply all these particular values, you will get the probability of binomial distribution. Let's talk about the another classification of the formula in this particular screen. If the n is greater than 0, that means the p and q is also greater than or equal to 0. It means that all of the trials, whether it would be the binomial probability of one success, binomial probability of second success, binomial probability of third success. That means the n is a number of trials. The probabilities, binomial probabilities of n number of trials, or you can say the number of successes. So when you add on, which always been equal to 1. So this is, as I already told, when the summation of the success and you can say failure is equal to 1. So from that particular concept, there is another formula of binomial distributions when the number of trials being conducted is whatever. It would be a limited number of trials. It would be you can see more number of trials. So once you get the trials and when you get the probabilities of that trials, that once you add that values, it should be equal to 1. So this is called another conceptual, or you can see a theoretical formula. So it can be obtained. This formula can be applied when the n and p must be known. That means it is given in the question before applying. So if the n and p is given in the values of these two important variables given in the question, then you can apply this formula. Otherwise, you cannot apply this formula. So it means you have to apply the first formula where you need to calculate p and n and x and b as well. So this particular approach will always be exist when the only the two parameters will be given, and that's why in other words it is called the bioparametric distribution as well. So this particular term is denote two main you can say concepts. That is, first one is Bernoulli theorem, and the second one is Bernoulli distribution, and the third name of this particular distribution is a bioparametric distribution. So don't be confused if it is in the question it is given. Please just give a short note about the bioparametric distribution. It is a binomial distribution as well. How it would be is you identify binomial because its bi has been mentioned, that means is binomial. It means twice or two possible outcomes. Let's talk about the mean and variance of the binomial distribution. This is also the another theoretical framework where the mean, variance, or standard deviation has been defined, and how to calculate the probability of a binomial using the mean, variance, and standard deviation. These are the formulas has been given to you. That is, mean is equal to n into p, variance, which is called the square of standard deviation, that is n into p into q. N is a number of trial, p is a number probability of success, q is the probability of failure. So when you have a values of these three, multiply it, you will get the variance. So once you estimate the value of the variance, you can easily calculate the value of standard deviation. How? Just square root of all these values, that is n into p into q, you will get the standard deviation. But always be remembered what the value of variance of a binomial variable is always be less than its mean, and that is a rule under binomial distribution theorem, that the variance value should be less than the mean. So and if it is less than, then you can easily adopt this concept. If it is more than, so it cannot be adoptable. That means you can easily use either Poisson distribution or normal distribution accordingly. Let's talk about the properties. So properties, accordingly, it is the mean, variance, and three main important concepts of you can say under this particular approach. The properties are the mean, variance, and standard deviation. So there is a small example where the values has been given to you. That is, for example, you throw a coin 100 times. That is, n is equal to 100, p is equal to 0.5. Then how you calculate the mean? So if the values have been given in the question, you can easily calculate the mean and use these concepts if it is prescribed in the question. So mean is equal to n into p, that is n is 100 and p is 0.5. So once you multiply these two values, you can easily calculate the mean. Then how to calculate the variance? So the main question arises here. Obviously, the n is already given, p is already given, so q is easily being calculated. What is the formula of q? Q stands for 1 minus p. So there is a formula. If you see the formula over here, which I already told you, see, this is a formula has been given, success and failure. If p is given, you can easily calculate the q. Q stands for 1 minus p. So the same formulas will be applied in this particular scenario, that variance. So variance, how to calculate the variance? That is the standard square of standard deviation square, that is equal to n into p into q. So we have n over in the question, we have p, and q has been calculated, that is 1 minus p. 1 minus zero point 0.5, you will get the q zero point 0.5. So once you get all the values n, p, and q, just multiply these three values, 100 into zero point 0.5 into zero point 0.5, you will get the variance. So once you get the variance, you can easily calculate the standard deviation. So just square root of the variance. So variance is 25, just calculate the square root, which in the short scenario which has been given SQRT, it means square root of 25, it stands 5 only. So 5 is your standard deviation or standard distribution. So you can use any of the concept as the standard deviation or the standard distribution, both are same. So this is the properties you can say, and this is also the three main important elements of the binomial distribution. So where if there is no theoretical question has been given, you just given the three main values, you must know the formulas of these concepts, and accordingly you can estimate these three variables using binomial distribution. Why it is binomial? Because in this particular element, we are using the probabilities values, that is p zero point 0.5, probability of success, probability of failure, that is 1 minus p, and that's why it's called binomial distribution. Otherwise, if we don't use any probabilities, we can easily use the measures of central tendency, use the step deviation method, simple shortcut method, or simple method you can use to calculate the mean, variance, or standard deviation as well. So the first formula always been used when there is a possibilities of success. You need to calculate, a researcher has to calculate for the binomial distribution. So when you need to calculate the possibilities of success, possibilities of failures, you will use this formula which has been given, this, that is NCX, that is cumulative, or you can say value of x, that is px 1 minus p in by n minus x. So this formula will be used when you need to calculate the probabilities of success, probabilities of failure, and it's very easy to understand this formula, and it is very easy to know and easy to calculate as well, even you don't have any calculator. So if you have calculator, use you can say use that calculator. Why? Because I'm saying, because it reduce your efforts in time as well. It will reduce your time, and you can easily calculate the value, which manually it will take more time to calculate. So calculators is allowed to use in this particular subject, and you can use when calculators when the binomial, Poisson, and normal distribution concept or question is being asked in your examination. So alternate formula, let's talk about the alternate formula which has been shown, which is all probabilities of all the trials just add, and which is equal to 1. So it could be used when the n and p values will be given to you. So let's take a question over here. If the coin is tossed 10 times, then what is the chances of getting exactly 6 heads? So when you have this heads and tails, or you can, then we always use binomial. So when you have a, let's change the question. If the coin is tossed 5 times, then what is the chances of getting exactly 4 tails? So it's called binomial distribution, because here we can easily understand how I identify it as binomial, because here we are talking about to calculating the probability of heads. So head and tail is the two possible results of a coin. So it means binomial, it is a question of the binomial distribution. So this is a formula that we need to apply one by one. You need to estimate what is n in the question, what is p in the question, how to calculate the q. So once you calculate the n, p, and q, use the values in the question, and accordingly you can estimate the value. So n is a number of trial which is given 10. That means if the coin is tossed 10 times, so n is a number of trials, it's a number of times is n. So 10 is your n. The odd, that means success. You need to calculate the probability of success. So probability of success is always being 0.5. Why I'm talking about the success? Here we are talking about the head. So when you toss a coin, it would be a possibility of coming head. That means half of head version and half of the deal. So when you calculate the half, it stands for 0.5. So when we calculate the failure, the probability of the failure, that is 1 minus p, and that is equal to q is equal to 0.5. So this is a question over here. So what is the question? That you need to calculate the chances of getting exactly 6 head. So your x would be 6, because whatever we are calculating, that is called x. So x is given, n is also given, p is also calculated, q is also calculated. So just put the values into the formula. That is 10 cumulative, n is 10, cumulative 6 into 0.56 into 0.54. So once you get the values, 10 factorial 8, so 10 factorial, what is the factorial of 10? That means 10 into 9 into 8 into 7 into 6 into 5 and so on. Factorial of 6, that is 5, 6 into 5 into 4 into 3 into 2 into 1. So once you divide all these, so multiply, divide, you will get 210. So once you multiply 0.56 number of times, you will get the value 0.01565. When you multiply 4 times 0.5, you will get the 0.625. So once you multiply all the values, you will get the probability of binomial distribution, that is 0.205. So if we talk about, it is that p value is less than the p. So that means if the p is 0.5, right? So it is the skewed distribution. When p is more than values more than the p, that is 0.5. If the p is more than 0.5, it is a negative skew. So what is the p value here? P is 0.20. It means it is a positively skewed binomial distribution. Why it is positively skewed? Because p value is less than 0.50. If it is p is 0.50, it is skewed. If p is more than 0.50, it is negatively skewed. If p value here is 0.20, it means it is positively skewed. Why it is positively skewed? How you interpret the value of probability here over using this approach? How? So if the p value is less than the 0.50, it is a positively skewed binomial distribution. So this is a way that how you interpret the probability values using this particular distribution approach. So this is a way to interpret the results in statistics or in mathematics. So there is another question that 80% of people, those who purchase pet insurance, are women. If the owners of 9 pet insurance are randomly selected, that find the probability that exactly 6 out of them are women. So this is a particular another question for you. So this is a way that you need to follow up the. So 80% of the people those purchased pet insurance are women. So here in the particular question, P is already given to you 80, that is 0.80. As 80%, it means the 80% chances of the people, those who have purchased pet insurance are women. That means 80% chances of women who have purchased net insurance. That means P over here is 80, that is zero point 0.8. So now you can easily calculate the Q. What is the formula of Q? That is 1 minus P, that is 1 minus zero point 0.8. That means 20% is the failure. Now let's do the second part, that how to calculate that value of 6, that probability of 6 number of times. Why x is 6? Because in the question you need to calculate the probability that exactly 6 out of them are women. So that's why x is 6. If it called 10, x is 10. If it is called exactly 4, x will be the 4. In the similar question, you need to calculate exactly 6 heads. So x is your 6. So in this question, exactly 6 out of them are women. So you need to calculate x would be the 6. So x is 6, then obviously then p is zero point 0.8. So once you multiply 0.8 6 number of times, you will the values being here, that is 0.262144. So once you calculate, so these are the part of the formula, that is 1 minus p. What is 1 minus p over here? Is q, n minus x. So Q n minus 6 would be, the Q is 0.2, 9 minus n is 9, x is 6. So you will easily calculate the Q. So once you get all the values, just multiply all the values, that is 0.176. As it is less than 0.50, so automatically it is a positively skewed. So this is a way that how to use the binomial distribution formula. You need to calculate, you need to find out the n, p, q and x. So once you calculate all these 4 important variables, the value of these 4 variables, you can easily use this formula, and accordingly you can calculate the probability values of the variable which has been mentioned in the question. So this is the solution. This is in, you can see the result of the binomial distribution. So with the use of these formulas, whatever the formulas has been taught over here, you can calculate the binomial distribution very easily. Because the process to find out that is true, it's not so easy, and as it is a lengthy process as well. But whatever the small steps that we have that I have taught in this particular session, it will be helpful to find out the probabilities values of a head and tail using the binomial distribution. So it will be very helpful, these formulas, to find out the binomial distribution easily. Let's talk about the Poisson distribution. When we talk about the binomial distribution, we have always talk about the exact limited number of events or limited number of trials in case of binomial distribution. But in case of Poisson distribution, the number of times an event occurs and number of times it doesn't occur. So when we talk about the Poisson distribution, we know the number of times a particular point is occurred. It's very well known, but number of times it doesn't occur, that means a probability of both in case of binomial distribution. But when we talk about the Poisson distribution, here the case is reverse. That is when the n is large and the value of p, that means n is a number of times, is a you can say large values. It would be 100, it would be 500. The value of p is very small, but such cases arise in case of rare events. So what exactly the Poisson distribution saying over here? It refers that Poisson distribution models that obtains the you can see the n number of you can see the values out of all those possible outcomes in a population, not in a sample, in a population. When we talk about binomial distribution, here we are talking about the number of times, the number of two outcomes in a sample, right? But in Poisson distribution, here we are not consider any samples. Here we are consider include everything, whether n, whether p, but in a population. We are talking about the road accidents in a population. We are talking about the death in a floods. That means in a rare events, it's a natural calamity events, that number of accidents of the students who jumped from the tree, jumped from the roof. So we don't know the rare events, anything could happen, how you will calculate the probabilities in that particular scenario. Know how you will evaluate the accidents, road accidents, in case in such. So in that particular cases, you need Poisson distribution, where you need to calculate the distribution of probabilities of the possible outcomes, when it in case in a population or in a case of the rare events. That is number of road accidents, number of death in floods, number of mistakes per page as a typist, number of accidents, number of goals in a games. So these are the possibilities where the Poisson distribution could be used, because it is a natural events, it is a rare events where we use the Poisson distribution, not binomial distribution. So it has happened in binomial. We know there is two possible outcomes, but in the Poisson we don't know the possible outcomes. So in that scenario, we will use the Poisson distribution, because here we are talking about, or we are calculating the probabilities of all Poisson variables in case of rare events or in a case of population. So that's called Poisson distribution. These are the follow-up examples to have a more clarity about the Poisson distribution. The number of customers who call to complain about the service problems per month. If you talk about the number of visitors appears on a website per minute or per seconds, the number of calls to consumer hotline in a 5-minute period. So it is, you assume that how many telephone calls being received in a small business or in a large business during a 5 minutes. So accordingly, you will use, because here we are not consider any you can say samples. Here we are considered as a you can see population, a community, a organization, a company, right? So that's called, in that particular scenario, we use Poisson distribution. Here we talk about the airlines, here we talk about the arrivals in the airlines, any network failures, any asthma patient arrivals in a given hour and walk-in clinic. So how many numbers, hungry person in a particular region, like for example in the MACD's restaurants, if you go to the MACD restaurants, you need to calculate at how many people who are hungry and they need food of MACD or they need food of any other restaurants. We use Poisson distribution, because here we are talking about the population. The number of birth, death, marriages, divorces, suicide, homicides over a given period of time. Here we are talking about the population. Number of males, females. That means we are in that particular whole scenario, we are using the Poisson distribution, and that is the main difference between the binomial and the Poisson distribution. Binomial stands for two possible outcomes, but Poisson doesn't stand for two possible outcomes. We are obtaining the probabilities of a population, the values of probabilities of a number of trials in a population, not in a sample. So this is called the Poisson distribution. These are the features, the whatever the occurrence of an event is independent of other events. So that means one event is dependent to another events. So that's called the Poisson distribution, where independency you can see always be there, but the time period is would be the same, where n and p, which is equal to m, is finite. So in the Poisson distribution, we cannot say it is infinite number of values. It always be infinite. So when we talk about infinite number of values, here we are talking about a normal distribution. Because why it is infinite? Because here we talk normal distribution, we talk about the continuous data, but here we're talking about the discrete data, so definitely it would be the finite values. P is a constant probability of success, which is always be, you can say whatever the value would comes, it would be the small value. So that's called the probability of success. The infinite numbers of occurrence, that is n, which is called a number of trials, and definitely it would be large. N could be infinite, n, but not n p is equal to m is finite. That means the n is infinite, then p is also infinite, and m is also infinite. No, n could be infinite, but the p and m would not be infinite. So that is the rule of the Poisson distribution, because if the everything is large, it becomes normal distribution. So that's why it's called Poisson distribution as well. So as it has been in a discrete distribution, or as compared to binomial distributions, so trial operates continuously over some given amount of time. So whatever the trials being given, about the trials of the how many marriages being done in a particular region or in a particular area, so automatically the trials operate continuously to get to know that number of marriages being done in a particular area or over some period of time. So here that's we call the Poisson distribution, because here we are talking about the population, not any samples. Condition of Poisson distribution. So these are the event could occur any number of times, event occur independently, and conditions for Poisson distribution. The rate of occurrence is obviously whatever the rate or whatever the changes will not being done based on time. So whatever the probability of an event occurring in a is very proportional to the length of the period. So whatever the calculation is to be done, whether it's birth, it's a number of trials, and according to the period of time, it would be 2 hours period, it would be 3 hours period, or any event to occur within a 1 hour period, and that is the conditions of the Poisson distribution. So once you are calculating any probability, it should be based on time. So that's the Poisson distribution. This is also the identification of Poisson distribution. Why I'm saying this? Because most of the students and learners would become confused, or because in the question it's not been prescribed at using the Poisson sometimes or using the binomial. So you need to identify whether it's a question of the binomial, it is a question of the Poisson distribution. So in binomial is automatically, it's very easily understandable that it's two possible outcome, head and tail, any other success and failure. So when we talk about the Poisson distribution, we are not talking about success and failure. We are not talking about head and tail. We are talking about to calculate the probabilities of various events which has been occurred in a world or in India or any other country region, and that's that here that we use the Poisson distribution. Assumption sample size could be large, as I told, n could be infinite, but not p and m. So Poisson distribution, that success value of x should be 0 as well, and the Poisson distribution, which is the non-occurrence of any probability of failure, is approaching to 1. So assumption is also that we don't know the probability of non-occurrence of an event. So in the question binomial, we know the value of success and failure as well. But in the poison, we don't know about the failure. We don't know about whatever the event which has not been occurred. Nobody knows, and that is an assumption in the poison distribution. Poisson is a limiting form of binomial distribution. N becomes infinite, P approaches to zero, NPM remains fixed, N is approaching towards the infinity. So which I already told earlier as well, that N becomes infinite, P becomes zero. Definitely it could become 0.1, 0.01, and Q will always be in 1. So these are the assumptions. So we cannot take an opposition against about these assumptions. These are the assumptions which has been prescribed in the you can say when this concept has been introduced or published. So these assumption is being followed up. Applications where these are the applicant applied areas where the poison distribution can be applied. It could be birth defects or genetic mutation, car accidents, traffic and idle gap distance here found in MACD. If you see the KFC, there are in the earlier previous years, there might be a cases where the insects has been found in the you can say chicken in KFC restaurants. So poison distribution can be applied. A probability of the insects found in the KFC chicken. So this is also the one of the example, one of the application where the poison distribution can be applied. Failure of a machine in 1 month, it could be 1 month, it could be 2 months, it could be any months. So poison would be applied. When we talk about the these particular poison distribution approach, there is a tool which need to apply as a coining theory. So when we talk about the any waiting time, any gap of time, there is a theory which is called the coining theory. So this theory is always denotes that refers to a problems related to the waiting time, relating to any idle gap time. So when we talk about the problems related to the waiting time, we always use the approach. Theory here is a coining theory. The following approaches, the models, the mathematical theorems will be applied to estimate or to resolve the problem of the waiting time or idle gap time between the machines, between the any other variables. Demand for a product in equal intervals of time, arrival pattern in a departmental stores, the occurrence of defects in a manufacturing units. So these are the particular examples where you can say poison distribution will be applied. This is a short example of Poisson distribution to have a more clarity that how to use the mathematical formula in the Poisson. The average number of homes sold by HP Realty Company is 2 homes per day. What is the probability that exactly 3 homes will be sold? So Poisson distribution that you need to, this is a formula has been given of the Poisson distribution. So pi is equal to 2 since 2 homes are sold per day on an average. X, why is X is 3? Because in the question it's asked a probability of exactly 3 homes. 2 homes per day because it is an average. So mean is 2. That means mean that is 2 has been given. E is a assumed value which is always been concerned. So it is given in the question E, the value of E, that is 2.71828. Why mean X and E has been calculated before applying or before calculating the probability using the Poisson distribution? Because the formula states for this only. That is E is equal to minus N, that is mean is equal to X by X. So once you get the values of mean X and E, use these values or apply into the formula. So once you apply these values into the formula, you will get the value of probability of exactly 3 homes which will be sold tomorrow, that is 0.108. 180. So the probability of selling 3 homes will be 0.180. So that's it for today regarding the probability distribution, which is also the one of the most important concept and version of probability distribution, that is binomial and Poisson distribution. So that's it for today. So just prepare it well, and thank you so much, and namaste to all.
Nice.
Thank you.